Our story begins. It is a tale of human ingenuity, a testament to our unyielding curiosity. Picture the scene, 1977. Earth. We looked to the stars as we always have, but this time, we were doing more than just looking. We were reaching out. Voyager 2, a marvel of engineering, was poised for a journey unlike any before it. Its mission was audacious, a grand tour of the outer solar system. Jupiter, Saturn, Uranus, and Neptune. These colossal worlds awaited our emissary, a tiny spacecraft carrying the hopes and dreams of a planet ready to explore. The launch itself was a spectacle, a controlled explosion, defying gravity. On August 20, 1977, a Titan IIIe Centaur rocket roared to life. It carried Voyager 2, a mere 722 kilograms of scientific instruments and ambition. Its primary objective was clear: to study these gas giants up close, to unveil their secrets, their atmospheres, their rings, their myriad moons. Each encounter was meticulously planned, each flyby a ballet of physics and engineering designed to gather precious data. It was a cosmic billiards game, using planetary gravity to slingshot from one world to the next, an elegant dance across billions of kilometers. Think about the technology of the time, the late 1970s. Computers with less processing power than your smartphone. Yet, we built a machine capable of navigating the vastness of space. It had to be robust, it had to be autonomous to a degree. Light takes hours to travel to the outer planets and back. Real-time control was impossible. Voyager 2 was designed to think for itself to an extent to handle unforeseen circumstances. It was a bold gamble, a testament to the scientists and engineers who poured their expertise and passion into its creation, hoping it would survive the harsh radiation and the cold emptiness. This wasn't just about pretty pictures, though the images it sent back were breathtaking. It was about fundamental science, understanding planetary formation, seeking out the conditions for life, exploring magnetic fields of unimaginable scale. Voyager 2 carried a suite of sophisticated instruments, cameras, spectrometers, magnetometers, plasma detectors, each designed to probe, to measure, to analyze. The data it would gather promised to rewrite textbooks, and it did. It fundamentally changed our understanding of our celestial neighbors, revealing worlds more dynamic and complex than we had ever dared to imagine. The Grand Tour was more than a mission, it was a voyage of profound discovery. Voyager 2 did not just complete its initial mission, it excelled. Jupiter revealed its turbulent Great Red Spot in unprecedented detail. Saturn's majestic rings showed intricate structures, braids, and spokes, baffling and beautiful. But the probe was built to last. It kept going. Uranus, the sideways planet, offered up new moons in a strange offset magnetic field. Then came Neptune, a brilliant blue marble with the fastest winds in the solar system and the enigmatic Great Dark Spot. Each encounter was a triumph. Each dataset a treasure. Its initial planetary assignments were fulfilled with spectacular success by 1989. But the journey was far from over. This little spacecraft, designed for a few years, just kept on going. It became a testament to engineering resilience. Think of the challenges, the sheer distance, the dwindling power from its radioisotope thermoelectric generators, the cold, so intense it could make metals brittle. Yet, Voyager 2 persevered. It was heading out of the solar system, towards the heliopause, the boundary where the sun's influence wanes and interstellar space begins. This was uncharted territory. A new mission phase, the Voyager interstellar mission, began, pushing the boundaries of exploration further than ever conceived by its creators. Communicating with Voyager 2 became an epic feat in itself. Imagine whispering across billions of kilometers. The signals, traveling at the speed of light, still take many hours to cross the gulf. The Deep Space Network, with its giant radio antennas scattered across Earth, strained to listen. The spacecraft's transmitter, powered by less energy than a refrigerator light bulb, sent back faint whispers of data. These signals, incredibly weak by the time they reached us, had to be painstakingly amplified and decoded. It's a cosmic dialogue, a fragile link to our distant robotic pioneer, a connection maintained by sheer determination and technological prowess. On November 5, 2018, decades after its launch, Voyager 2 made history. It crossed the heliopause. It entered interstellar space, the space between the stars. It joined its twin, Voyager 1, as the only human-made objects to achieve this monumental feat. It was now sampling the particles and magnetic fields of the Milky Way galaxy, unperturbed by our sun's bubble. The data it sent back from this new realm was unique, invaluable. It was our first direct taste of the galactic environment, a tiny ambassador carrying a golden record with the sounds and images of Earth venturing into the cosmic ocean. Its longevity is a marvel, far exceeding all original expectations. Then, something unexpected happened. In the spring of 2010, long before it crossed into true interstellar space but well into its journey through the outer heliosphere, Voyager 2 began to send back, well, something strange. The data stream, usually a clear if faint flow of scientific information, became corrupted. It wasn't just noise. It was as if the spacecraft was trying to speak, but its language had suddenly changed. For weeks, the science data it transmitted to Earth was unreadable. This was not a complete loss of signal, which might indicate a catastrophic failure. Instead, it was a distortion, a puzzling alteration in the information it was dutifully sending home. The mission controllers at NASA's Jet Propulsion Laboratory were, understandably, concerned and perplexed. Voyager 2 was nearly 14 billion kilometers away at the time. You can't just send a mechanic. Every command, every diagnostic test, took almost a full day for the round trip of communication. The team worked tirelessly. They scrutinized every bit of telemetry. Was it a hardware failure? Had a vital component finally succumbed to the decades of harsh radiation and extreme cold? The spacecraft was old. Its systems were ancient by modern standards, yet it had been so reliable for so long. This sudden anomaly was deeply unsettling for everyone involved in the mission. The peculiar nature of the corrupted data deepened the mystery. It wasn't random static. Some reports suggested that one specific part of the telemetry, the part that formats the science data for transmission, was the issue. The spacecraft itself seemed to be otherwise healthy. Its engineering data, the information about its own operational status, was still coming through clearly. This suggested the problem was localized, specific to how the scientific observations were being packaged. But why would only that part fail, and in such a peculiar way? It was a genuine puzzle, a whisper from the void that we couldn't immediately comprehend. Theories began to circulate, as they always do when confronted with the unknown. Could it be an external influence? Some unknown phenomenon in the far reaches of the solar system affecting the spacecraft's sensitive electronics? Or was it simply the inevitable decay of a machine operating far beyond its warranty, a single, critical component finally giving up the ghost? The silence from the science instruments, replaced by this garbled message, was a stark reminder of Voyager 2's isolation. It underscored the immense challenges of operating a deep space mission, so far from home, where every problem requires ingenious long-distance solutions. The official explanation eventually came. After weeks of painstaking analysis, NASA engineers pinpointed the cause. It was a single flipped bit, just one bit of memory, in one specific location in the spacecraft's flight data system computer. This tiny error was responsible for corrupting the entire science data stream. A cosmic ray, a high-energy particle from some distant supernova or perhaps even our own sun, was the most likely culprit. These particles can, and do, wreak havoc with sensitive electronics, even those shielded on Earth, let alone a probe that had spent decades bathing in unfiltered space radiation. The solution? Engineers beamed up a command to reset that bit, and it worked. Voyager 2 was back to its old self, sending clear science data once more. While the official explanation was grounded in solid engineering and physics, the temporary mystery certainly sparked imagination. Off the record, or at least in the public's imagination, more exotic theories always find fertile ground. Could it have been something else? An attempt at communication by an unknown intelligence, subtly altering the data stream? Highly unlikely, of course. There was no evidence for such a dramatic interpretation. But these moments of the unexplained, however brief, remind us of the vastness of space and the potential for surprises. They fuel our what-if scenarios, the very questions that drive us to explore in the first place. The universe is a big place, and we've only just begun to listen. The implications of Voyager 2's continued journey, and even this minor hiccup, are profound. It demonstrates our ability to build machines that can endure for decades, traversing unimaginable distances and hostile environments. It pushes the boundaries of our knowledge, providing direct measurements of interstellar space. Every piece of data it sends back refines our models of the galaxy. It helps us understand the protective bubble our sun creates around us, the heliosphere, and what lies beyond it. It gives us context for our own place in the cosmos. We are not isolated. We are part of a much larger, interconnected galactic environment, and Voyager 2 is our intrepid scout. Ultimately, Voyager 2 and its brief, mysterious signal change our perception of the universe by underscoring its immense scale and our tenacious ability to reach into it. It highlights both the fragility and the robustness of our technology. It reminds us that even a single bit of data can hold immense significance. This mission, born in the 20th century, continues to teach us in the 21st. It whispers tales of the cosmos, not just through its intended data, but through its very existence, its endurance, and its occasional puzzling behaviors. It's a constant reminder that there is always more to learn, always more to explore, out there in the grand cosmic expanse.